f of x dx. Okay, so that would be 1. So we're going to treat them as two separate intervals, plus the limit as k goes to positive infinity of the integral from 0 to k of f of x dx. Okay, so let's take an example. Integral from negative infinity to infinity of dx over 1 plus x squared. So what that looks like is sort of this bell curve thing here. It should be perfectly symmetric. So we want to find this whole area there. So let's split this into two integrals, and should we use 0 as our dividing point?
Yeah.
Okay.
Because then you only have to do it once, right? Because it's even.
Yeah, exactly. So, yeah, that's a good point. You could change it because you know it's even, but this only works if it's even. You could change this to 2 times the integral from 0 to infinity, right?
Yeah.
Okay. All right, so now I have, for the sake of this argument, we're going to do it out twice just so we can see how that process works.
Yeah.
So the limit as b goes to infinity, negative infinity, of b to 0 of dx over 1 plus x squared, plus the limit as k goes to infinity of integral from 0 to k of dx over 1 plus x squared. So what is the integral of dx over 1 plus x squared?
Is the substitution?
No, this is one of
Oh,
those.
is it tangent inverse?
It's tan inverse, right? Okay, so this is the limit as b goes to negative infinity of tan inverse of x, evaluated from b to 0, plus, again, same thing, the limit as k goes to infinity of tan inverse of x, evaluated from 0 to k. Okay, so plugging this in, we have the limit as b goes to negative infinity. So we have tan inverse of 0, right?
Yeah. Minus
Tan inverse of b. Plus the limit as k goes to infinity of tan inverse of k minus tan inverse of 0. All right, so tan inverse of 0 is what? Where's the tangent equal to 0?
Sine is 0, so 0.
0, right. Okay. So tan inverse of 0 is 0, so this is 0, this is 0. Okay, so the limit as b goes to negative infinity, so what's the tan inverse of negative infinity?
Oh, isn't it also 0?
No. So here's one period of the tangent graph.
Yeah. So
Right.
negative or positive pi over 2.
So if we're going to negative infinity, right, that's down here, this is the value. Right, we're going to, so it's negative pi over 2, right? Okay, is that what you said?
I said positive. I was
Well, it becomes positive because it's minus a minus pi over 2,
Oh, yeah.
right?
Yeah.
And then over here we have tan inverse of also infinity. So what is it here?
Pi over 2.
Pi over 2. So we have pi over 2 plus pi over 2, so that gives me pi as an answer. Right? Okay, so now we're gonna look at the case where there is an asymptote at A or B, so at one of the ends. So here we had, this was negative infinity to infinity, so we're gonna look at an asymptote at one of the ends. So, one and we have the integral from 0 to 1 of dx over square root of 1 minus x. Okay. So there we have an asymptote. Where is this undefined?
At 1.
At 1. Okay, so 1 is our problem. So that's the thing we need to change, right?
Yeah.
So we're gonna say the limit as b goes to 1. Okay, now, we're coming in from which side?
The left.
The left, right? So that's important here. We're coming in from the left because we're going from 0 to 1, okay? Integral from 0 to b of dx over square root of 1 minus x. Okay, so, let's see. What is that integral? This.
Is that, that's not a inverse trig, is it?
It's not an inverse trig, no. It's just gonna be a straight u substitution.
So,
So-
negative.
You can think of u as 1 minus x, so du is negative dx, isn't it?
Yeah.
All right, so we're gonna have integral. Let's just write this as u to the negative 1/2 power with an extra negative sign, right?
Yeah, so.
Okay. So that when we integrate it, what's it gonna be?
Negative 2u to the 1/2.
Oh, sorry, 1/2, and then, so negative 2, okay. So plugging back in our u substitution, this would equal the limit as b goes to to 1 from the negative of negative 2 times 1 minus x to the 1/2 evaluated from 0 to b. So let's plug in b, the limit as b goes to 1 from the negative of negative 2 times 1 minus b to the 1/2 minus, we still have a negative 2 up front, 1 minus 0 to the 1/2. Okay, so as b approaches, gets close to 1, what happens in here?
It goes to 0.
This goes to 0, so this whole thing just goes to 0. Okay, so here we have 1 to the 1/2, which is 1,
Yeah.
times 2 negatives, right? So this is equal to
2.
2. Good. All right, so what would happen, or how would we handle the case when we have an asymptote in the middle of our region?
Would you break it up at that point?
Right. So let's take an example. Let's do the integral of, let's see.
1 over x squared.
Yeah, I was gonna say x over x squared minus 9, and we're gonna go from 1 to 4. Okay, 1 to 4. So, x squared minus 9 has 2 asymptotes, right?
Yeah, but only at 3 this one.
So 3 is the only one that we're concerned about?
Yeah.
So we have to split this up into 2 integrals. I'm going to write this as the integral from 1 to 3 of x over x squared minus 9, plus the integral from 3 to 4 of x over x squared minus 9. I added that x in the numerator so that it would be easier to integrate, right?
Oh, yeah.
Yeah. I could have added a 2x, that would make it a lot easier. Okay, okay, so now, what are we gonna do here? We're gonna rewrite this as the limit, as b goes to 3 now from which side?
On the left in this one.
The left, right?
And the right in another.
Okay, so integral from 1 to b of x over x squared minus 9, plus the limit, as we use another variable k, goes to 3 from the positive of integral from k to 4 of x over x squared minus 9. Okay, so what is this integral here?
So we use x squared minus 9, du dx is 2x, so du, or dx is du over 2x. So it would be 1/2 times ln absolute value of x squared minus 9.
Good. Okay, and we still have the limit as b goes to 3 from the negative, evaluate from 1 to b, plus, okay, now we have the limit as k goes to 3 from the positive, same antiderivative, right? 1/2 ln x squared minus 9 from k to 4. Okay. This is interesting. Because as we're going towards 3 from the negative, ln of something, that's gonna be undefined, isn't it? Is this number, when we come in from the 3, from the negative?
But isn't it squared, so
Yeah, but it's not gonna if it's from the negative, isn't it gonna be slightly less than 3? If and I square it, it's gonna be slightly less than 9, right? Yes, we have so we have a problem with this one here. Okay, maybe that wasn't a great example. Okay. What does this graph look like? It has a root at 0, asymptote at 3, negative 3. Something like that, I think. We're going from 1. Okay, so this one is a problem. I can't plug in B here, right?
yeah, if you did this on your calculator and there was like an asymptote, would it know how to do this or not?
I don't know, you can try it.
I'll try it.
This one I think we can do. This is gonna be 1/2 ln of 16 minus 9, so ln 7, minus 1/2 ln of k squared minus 9. So that's gonna be almost 0, so that's gonna be infinity, right? So this whole thing, I think, diverges.
So, it's taking a while, but it's not saying I can't do it.
Okay. Okay, so I think that's it for the notes. So do you mind turning that
Yeah.
off? Thanks.